We've arrived at a store with $30 in our pocket, let's say, and we need to purchase some items. The question is, do I have enough money with me to buy the items that I need to purchase? Well, what this brings up is a common, everyday mathematics situation. How do we know whether we have enough money? Well, what we're going to need to do is estimate the cost of each item, then add those costs together and compare that to the $30 that we have to see if we have enough money to buy the items. Well, let's look at these items. This particular item was $14.98, or approximately $15. This item was $8.98, or about $9. And this final item was $2.98, which is an estimate of about $3. Well, let's add our estimates together. $15 plus $9 is $24, plus the $3 is $27. So that 27 being less than 30 tells us that we should have enough money to buy these items. Well, now actually what have we done? Well, first we estimated the cost of each item, and then second we added those estimates together. And third, once we got that approximate total, we compared it to how much money we had. Well, let's use the calculator to find the exact total, and this will tell us whether or not we've made a good estimate.
Your children come home and want your help with the math they're learning in school. Young children usually need help with ideas like addition and subtraction, multiplication and division. You can help them many times with things that you have around the house. For example, the idea of addition. Dominoes is something that most of us have, and I'm going to use this large one to give you an idea of how it might be used. If you look at this domino, you can see that on one side I've got 5 dots. 1, 2, 3, 4, 5. And on the other side I've got 3. 1, 2, 3. It can be used to show the concept or the idea of addition in that 5 plus 3 equals 8. If we count, we can see 1, 2, 3, 4, 5, 6, 7, 8. 5 plus 3 equals 8. I could use the domino also if I turn it around to show that it doesn't matter if I start with 5 and add it to 3 or if I start with 3 and add it to 5, because the number of dots still remain the same. 1, 2, 3, 4, 5, 6, 7, 8. 3 plus 5 also equals 8. That's how we can show the idea of addition using the domino. Once children understand the idea of addition, then they can be helped to expand it to larger numbers. For example, if 5 plus 3 equals 8, then 50 plus 30 would equal 80. In the case of adding other things, like money, for example. Let's see how we can use something else for the idea of subtraction, like a can of soda that probably is just sitting in the refrigerator. We want to show children that subtraction means taking away. So if I had a 6-pack of soda and I were to give one child a can, that would leave 5 cans from the original 6, because 6 minus 1 equals 5. If another child drank a second soda, I would have only 4 left, because 5 minus 1 equals 4. So the children can be helped to understand that subtraction is taking away, and that by taking away, in this case, 2 from 6, I would have 4 left. The same idea could be used to explain other areas in which subtraction is applicable. For example, again, using money. Suppose they have 60 cents, and they want to know how much money is going to be left if they spend 20 cents of it. Again, 60 minus 20 would equal 40. This is a way that the idea of subtraction can be used using just a can of soda. The can of soda would also be helpful in helping us show something about multiplication. With this can, I can see that if there are 6 sodas, they're actually grouped. They're grouped into groups of 2, for example. They're 2, 2, 2. 3 groups of 2, so 3 times 2 also equals 6. Your children might insist that why multiply that when they can just count? It's easy to count from 1 to 6. They may even suggest that if you had 2 6-packs like I have here, 6 and 6, 2 times 6 equals 12, why multiply that? They can count to 12. But what if I had 7 6-packs of soda? Would it be equally as easy to count the 7 6-packs of soda, each containing 6? Or wouldn't it be easier to understand and learn or memorize that 7 times 6 or 6 times 7 equals 42? This way we can emphasize to them the importance of learning their multiplication facts, because it certainly helps to make multiplication quicker, or addition quicker in this instance. Finally, let's show an example of how we would use something to help to teach division. A box of cakes, something that I have around the house. I keep them because I like them too. In this box of cakes, there are 8. 2 children each need to get an equal amount. Well, you could have them understand that they could certainly open the box and pass them out one at a time until they were all gone and discover that each child ended up with 4. But division involves understanding that if I've got 8 cakes and there are 2 children, I can divide 8 by 2 and quickly find out that what I get is 4. 4 cakes for each child. Once more, this is a useful idea because it can be used in other areas other than trying to divide up the number of cakes. It could also be used, let's say, if grandmother sent some money and explained that each child was to get an equal amount. $46, let's say, divided between 2 children. How much would that be? 46 divided by 2, each child would get $23. We use several items to show how children can be helped to understand the ideas of addition, subtraction, multiplication, and division. But the thing I really want to stress is how important it is to show children the usefulness of mathematics and its importance as well.
Ann and I are going to talk about answering questions that our children bring to us from school. Now, Ann, I know that you're experienced at helping parents help their children.
I enjoy working with parents and working with my own children. And when your children first come home from school, they might bring some addition work, and a number line is a good place to start with helping children to understand addition. When children join items together, and it could be anything, we have blocks here, they're really doing addition. And if I took 3 blocks and I added 2 blocks, I would have a total then of 5, which is really the addition problem. 3 plus 2 equals 5.
Right, and as you mentioned about the number line, a number line is a very, very effective way of helping a child to understand the connection between this symbol, this 5, and the number of objects 5, no matter what objects we're using.
And you know, they may come home a little bit later on with what seems to be a more difficult problem, and it really isn't. It would be 30 plus 20 equals 50. Subtraction also can be seen with these blocks and compared to the number line, where we have a set of 5 altogether, and we take away, and you'll hear the children say take away, which is subtraction. So 5 minus 2 leaves the 3 blocks.
And again, the numeral down here on the number line helps us
It's right there, you can see it.
Right, and we can make that match between them. Now, most homes don't come equipped with a number line
Right.
quite like this one. However, we all have measuring instruments like rulers or, in this case, a yardstick. And although it doesn't have a 0 on it, all the other numbers are represented, and we can help our students, our children. Maybe we could use pennies or any other kind of marker.
Anything you can find in the home, really. You could almost ask the child to empty his pockets. Another way of thinking of subtraction is to compare 2 groups. And here I took and I put 3 red blocks together, and I could compare that to the 2 white blocks. And I could see that the set of red blocks is bigger, is greater, and I might ask, how many more? And it's 1 more block greater, and it's really the problem 3 minus 2 equals 1.
Right, and this is the answer to our
And
subtraction problem, as these are kind of matched up. Well, once our children have brought home addition and subtraction, it kind of follows naturally that they next bring home multiplication.
Multiplication. And there are a lot of things in the home that you can use to help your child to learn multiplication. One of them could easily be these sets of soda. And if you look, notice that each set has exactly 6 cans in it. So you really have a multiplication problem here of 2 times 6 equals 12. You could also do it might be easy for the child to see, well, that's addition too. That would be 6 plus 6 equals 12. But when the numbers get really big, like one time my child brought home a problem where he had to find 5 dozen, and that would be really much too large to add up. It was much easier for him to multiply 12 times 5.
And you know, it's an important connection that 6 plus 6 is the same as 2 times 6. But as you just said, when the problems get bigger, then it doesn't make sense to add, and that's when we really need to multiply. Well, very often they'll come home with a workbook or
You'll
a
see
textbook,
something like this
and you might see something like this that isn't very realistic, but we can really make a match here. As you notice, that the cans came off of here, and for each square there is a can of soft drink. And so this really also demonstrates the same thing. Household objects are very helpful when we're trying to help our children.
Absolutely.
Well, we've discussed addition, subtraction, and multiplication. Well, the next step, of course, is division.
Division. And division is very difficult for children to understand. It's the idea of separating. And if we took a group of objects and put them all together and we wanted to separate them or divide them into groups, into smaller groups, that would be division. Here we have 9 objects, and let's divide them or separate them into sets of 3.
Okay. You know, it's kind of interesting. We use the word divide, which means, in this case,
Exactly.
to separate, and that introduces that for our children. And what we're looking at here, 9 divided by 3, we want to count how many equal groups we have, and we have 1, 2, 3 groups that have 3 in it.
And that
so
works
that's
very nicely.
That's our answer.
And we put our group back together, and we might ask, well, let's break that group of 9 in, or that set of 9 into groups of 2.
And so we really do the same thing, but instead of putting 3s together, we put 2s together. And what happens is we have 1, 2, 3, 4 groups of 2 with 1 left over. And it's important that not every division problem comes out necessarily
That's your
neat
remainder.
like the other one.
There are some times when the remainder is important, and sometimes when it isn't. If you divide up a check, you may want to know exactly what each person's share is. But if you're dividing a board into a number of equal pieces, you may not care about a little piece that's left over, a remainder. You drop the remainder. But there are times when you have to round the remainder to the next highest number. The team is going to an away game. You have 21 kids making the trip. Each car can take only 4 kids, max. How many cars do you need? 21 divided by 4 is 5, with 1 left over. You need 5 cars, plus 1 more car for the remaining kid. That's 6 cars in all. Come to think of it, with all the gear they have to take, 6 cars is not a bad idea anyway.
For 2 people, we recommend 1 pound, 8 ounce per serving for an adult. Let me see what we have here. I cut a piece this morning. This weighs out to .65.
So that's a little larger than the 8-ounce serving that we're talking about.
Since 8.
At first, yeah, it was .50 would be a half a pound.
Okay.
Is your father a bigger eater than? Okay, then this piece should work just right for him. And look at this piece here.
Excuse me, please. Okay. I have another piece here. See if this equals out to a pound. Equals out to a taste over a pound. Is this okay?
Yes.
Okay, the tuna is $12.50 per pound this week. That equals out to $12.63.
Oh, and this is a little smaller.
Yeah.
This one is going to probably weigh, that one weighs .35.
Okay.
So the 2 of them together, .35 and 65, gives you 1 pound even. Sometimes there's a little variance with the paper.
Yeah.
Okay,
So
good.
$12.50, sir.
Okay.
One of the most important things to a business person is knowing how much to charge for your goods and services. So the way we do that is we use our measuring stick and we figure out how big the piece is going to be. In this case, we've got 10 by 14. With an opening of 10 by 14, we will add 2.5 inches of mat on every side. So 2.5 plus 2.5 on each side will be a total of 5 inches to each of our measurements, which were 10 by 14. So we end up with a 15 by 19 inch frame. Then the way we figure them, you have to get to linear feet in figuring molding, and what we've done is started with inches. So we add each of the 2 sides that are 19 inches, which would be a total of 38, and each of the 15-inch sides, which would be a total of 30, and we come up with 68 inches. So the way we change inches to feet is to divide by the number of inches in a foot, which in this case will come up to be 5.6 feet of frame. Then we take that 5.6 and multiply it by the amount that the frame costs, which is $3 a foot, and we come up with our total, which in this case be $16.80. And that's what I would charge for the frame itself.